This is our DESMOS.com calculator. So I'm just going to plug in a function. So f of x equals 11,000 minus 1,500x. And as is often the case, the window does not seem to show what we're looking at. A lot of things that we're going to be looking at only have positive values. So I'm going to first shift everything over here so the axes seem to show mostly the first quadrant over here, but it's still not sufficient. So one thing I can do is if you press the plus sign, by default it just enters expressions like we just entered, but I could do a note or a table. I'm going to do table, and so in this table I'm going to let y1, I'm going to turn it into f of x1. If you just type in x1, it will automatically subscript in this notation. I'm going to plug in 0, which obviously plug in 0, we're going to get out 11,000. Press enter, plug in 1, and it's going to assume the pattern continues, and I can just keep on going, and I can get an idea of where the value is going to be positive, both for the x's and for the y's. So if I look at this, I could go over here to the little wrench up in the far right hand corner for graph settings. Notice I've got some control over what appears. You might like to see arrows on the ends of the axes. You might only want them going over to the positive sides in each case. All right, the x-axis you could actually label as x. Notice that x appears down here. And then also you could label the y-axis as y. Notice the y over here next to the y-axis. I can also change the axes to be what I want. So I want the x values to go up to at least 8, where it becomes negative for the first time. And so maybe I'll go out to about 9. Then over in the other direction, maybe -1 would be sufficient. Usually about 1/10 or less of whatever the maximum x value is. Works out fairly well for allowing the numbers to be seen here. For the y-axis, I need the y max to go to at least 11,000. So maybe I'll just change this over here to be 12,000. And then the numbers you see down here, up here above the axis instead of below. So I could change this to be about 1/10 or a little bit less of the 12,000. So maybe make that -900. So here I can see quite easily that the numbers are kind of where I want them to be. Having from -1 to 10, the -1 appears. Maybe I don't want to see that. So maybe you can change that to -0.9. You can see how you can kind of hide the numbers. I could also make the numbers a little bit bigger. Notice the little a and the bigger A here at the top. That'll change the font size a little bit. Let's see what else. Notice the grid lines. I could take away the minor grid lines. I can even change where the major grid lines are. So maybe instead of every 2, maybe every 3 for the x's. So I could just change this to be step 3. Notice how it jumps 3, 6, 9 now. All right, maybe we want to keep them at 2. Maybe we want to make sure that they're guaranteed to be 1. For the y-axis, maybe those tick marks should be every 1,000 or 2,000. So I'm going to do every 2,000. And so we can kind of see what we're looking at there. And if you want, you can check minor axis and kind of see what the minor axis would look like or not. Sometimes you don't want the grid at all. So in this case, I'm going to uncheck the grid. Looks a little bit cleaner. Okay. So I've seen the table and the function. Now you can notice you've got different elements over here. One's labeled 1 and one's labeled 2. I could just take 2 and slide it up above, and it becomes my number 1 and my number 2. And so this is one way to kind of graph a function, kind of play with a little bit. If I click on the purple dot here, notice the dot, the points go away. I just have the table. If I click the dot again, they come back. If I click and hold, I can change those things. I can make them open dots. I can make them X's. All right, there's a variety of things. You can actually change the size a little bit. So maybe I want to make them 15. Notice how they get a little bigger. All right, I can even change the color. Maybe make them blue to match the line itself. And so that's also the same over here for the function. If you just click and hold down, you could change it from a solid line to dashed or dotted. You could also change the thickness, maybe make it 5, make it more pronounced. Okay, so these are all things that you can play with. So just click that again, make it go away. So that's just graphing a function. Now, one thing the function does that I don't particularly like is if we're going to deal with values where x's and y's are both positive values, maybe this function shouldn't extend on forever. So one thing you can do up with the function, if I use my curly brackets, I can create an inequality, 0 less than x less than, what do you want to say, 7.333, and then bracket that off. Notice how it stops and starts at 0 and 7.3. So I go back to the line and I hold down the dot, maybe change it back to a solid line so I can actually see how it kind of extends to the axis itself. So these are things you can actually do when you're creating a graph. All right, let's assume that we're trying to find the equation of the function. So if we have a linear function and want to try to find the equation, what I can do is create a table and use that table then to create what's going to happen. So I'm going to do this. You can, if you click on the edit list here, the tools, I can click there and I can say delete all. And so it now converts it back to where I was. So if I want to create a table, you could hit the plus sign and choose table. Or if you want, you can just simply type in the word table and it will create one. So in this case, I'm going to say I know a couple points. Let's say at 2, it is somewhere in the neighborhood of, let's say, 8,000. And 5, we'll say, is 3,500. So I've got 2 points. Now, they are plotted. My window just isn't big enough to show them, but I do know how big it needs to be. It needs to go out to at least 5 for the x's and at least as high as 8,000 to show. So let's just go over here to Tools for the graph settings, and let's change the x's. Maybe go from -1 out to 10 again. That would definitely be far enough. And then let's see, let's change this to be about -700 up to about 10,000. And so now I can see that my points appear in the window. I wouldn't necessarily have to do this to find the equation, but now that I've done that, what I'm going to do is I'm going to click in the next available cell here, and I'm going to do this. I'm going to hit Y1, and instead of saying equals, right next to the 1 up in the top left of your keyboard, if you hold down Shift and hit the little tilde, the little wavy minus sign if you want to call it that, what we're doing is we're going to model Y1 as a function of X1. And so I can just simply put in mx1 plus b, that's our slope-intercept form. And in doing so, it will match up the points that you have lined up for your x1s and your y1s as they appear in the table. They'll also hold them as spots in your equation here, and then find out what m, the slope, and b, the intercept, must be to satisfy those 2 points being on the same line. And so it graphs the line in solid black. You can see the black dot here. I could click that and change, or I could just click it real quick and have it disappear. All right, but notice that the slope now is negative 1500. The intercept is 11,000. So if I wanted to create a function to play with, I could just call this f of x equals negative 1500 x plus 11,000. And that would appear there. So this is a similar function to what we had before. So if we go back to our graph settings, hit the tool with the wrench here, maybe change the y max up to about 12,000 so I can see the entire function. And again, if I want to stop and start it at the axis, I could, with my curly brackets, set 0, and I can do less than or equal to if I want x, and make that less than or equal to, what do we say, around 7.4, 7.3. And so by using this modeling technique right here, we can identify the parameters, the slope and the intercept for any linear function defined by 2 points. And this would be the same if you had multiple points, as long as they all lined up. So that's just a little bit of what you can do with DESMOS to kind of get you started playing with linear functions. This might be a little bit easier than playing with the calculator. You may be familiar with your calculator, but I think DESMOS is a great tool because you can actually copy and use these images in homework and other projects. Hope you enjoyed.